And here are the rest of the answers to the Unit 2 review for problems 41 through 50. Now you should have seen a couple questions like this on ALEKS, and I do like these, and they're pretty basic. We just want to find two functions, f of x and g of x, such that the composition of the two, f of g of f of x, is equal to h of x. So we usually let g of x equal the inside stuff, so that could be a 1 minus 7x. And then f of x would equal the outside stuff, so whatever we give it, we're just squaring. And that would be it, because f of g of x, which is h of x, would become f of 1 minus 7x, which is 1 minus 7x, that whole quantity, squared. So this would be our answer. 42, we're graphing again. So for this one, f of x is equal to a negative x squared, or the opposite of x squared. Our vertex would be 0, 0. The parabola would open down. There are no other types of shifts here. So we could just start here at 0, 0. It would open down. So if we're at 1 or negative 1, we would just go down 1, because negative 1 or 1 squared is just going to be the opposite of that, so negative 1. If we go over 2, 2 squared is 4, but then we go down to negative 4. Again, you can make a table of values, but this is what it would look like. Just the reflection of y equals x squared over the x-axis. Okay, I really like a question like this, so please make sure you practice plenty of these. Remember, these are just the problems from the ALEKS Unit 2 final exam review. So if you do this problem, you can enter in the answer, click on more examples, and it'll give you some more practice. So here, we just want to first figure out what is f of x plus h. Well, here's f of x, so we would get 3 times the quantity x plus h squared minus 7. So if I square x plus h times x plus h, before we distribute the 3, we'll get x squared plus xh inside and outside here, plus h squared minus 7. So we get 3 times the quantity x squared plus 2xh plus h squared. Now we can distribute the 3. We'll get 3x squared plus 6xh plus 3h squared minus 7. So that's this whole first part we just found separately. So now f of x plus h minus f of x all over h becomes this whole polynomial right here, 3x squared plus 6xh plus 3h squared minus 7 minus f of x. And because it's a binomial, I'm substituting this, and now I need parentheses, all over h. So now this becomes 3x squared plus 6xh plus 3h squared minus 7 minus 3x squared plus 7 all over h. So now anything without an h should cancel. 3x squares cancel, 7s cancel. So now we have 6xh plus 3h squared divided by h. Now I could divide everything by h, take an h out here, so technically I could factor out the h, 6x plus 3h all over h. So now I'm just left with 6x plus 3h. And that's it. All right, here we have a rational function, or rational inequality rather. So first I need to figure out the zeros, or where this is undefined. So I have a 0 that comes from the numerator, x minus 3 equals 0, so x equals 3. That's a 0. Where is this undefined? When x plus 4 equals 0, so that's when x equals negative 4. So I'm going to make my number line. I want to know where this function is going to be greater than or equal to 0. So I have really a vertical asymptote at x equals negative 4. And then when x is equal to 3, I have a 0. So I need to check negative 5. We could check a 0, and then we could check a 4. So I'm going to substitute this into x minus 3 over x plus 4, and we'll determine our signs here. So if I have a negative 5 minus 3, that's a negative, divided by negative 5 plus 4 is a negative. A negative divided by a negative is a positive. If I substitute in 0, 0 minus 3 is negative. 0 plus 4 is positive. A negative divided by a positive is a negative. Then I have 4 minus 3, so that's positive. Divided by 4 plus 4 is positive, so that's positive. So I also need to include where it's 0. It is not 0 here, it's 0 here. So the solution would be from negative infinity to negative 4, but I wouldn't include that. I would include the 3 though, so then from 3 to infinity. That's where this graph would be greater than or equal to 0. All right, we're going to do another graph here of a square root function. And again, it's probably just easiest. We could use transformations, but it's probably just easiest to make a table. There's nothing wrong with this. We just have to pick some good values. So whatever x values we pick, we have to be able to take the square root of it. So let's see here. We can't pick any negative values. So let's start with 0. Let's do the square root. We could do 1. We could do the square root of 4. We could do square root of 9. And then here's our leftmost point because x has to be greater than or equal to 0. So 0 is our leftmost point. So this would become 2 times the square root of 0 minus 3, which is negative 3. So we have 0, negative 3. So it would shift 3 units down. And then this negative 2 is going to work itself out here with our values. Next, we would get negative 2. Square root of 1 is just 1. And then minus 3. So that's negative 2 minus 3. So this will give us a 1, negative 5. Then we would have negative 2 times the square root of 4 is 2. Minus 3. So that's negative 4 minus 3 is negative 7. That would be right here. Then we would have negative 2. Square root of 9 is 3. Minus 3, that's negative 6 minus 3, so we would get negative 9. So we're at 9, negative 9. So it would start to look like this. And there's our graph. Our leftmost point here is at 0, negative 3. All right, for 46, there's 2 parts to this. So if we want to look at this, this is going to shift 1 unit to the right and double the y values here. So if we just make a table of values, I'm just going to pick the endpoints and then that corner that's right there. So we have the points negative 2, 4, 0, 0, and then 4, 2. And then so then we multiply the y value by 2. So when we shift 1 unit to the right, we're going to add 1 unit onto the x value. So negative 2 plus 1 will give us a negative 1, and then we're going to double the y value, so we're going to get a negative 1, 8. Here we're going to shift the x value 1 unit to the right, so I become a positive 1, and anything times 0 is 0. Adding 1 onto 4 will give us 5. We double the y value, so we're looking at these values. So we have negative 1, 8, 1, 0, and then 5, 4. All right, for 46b, we're going to do the same thing here as far as plotting some points. Plot here, here, and here. So this is going to be, we take the opposite of x, and then we're going to shift 4 down. So then we take y value minus 4. That's the easiest way to do this. So our first ordered pair is negative 4, 0. Our second ordered pair is negative 2, negative 4, and our third point is 0, 0. So then our new values, we take the opposite of x, that's going to be a 4, and we do the y value minus 4, so that's going to be a negative 4. Take the opposite of x, so it's a positive 2. Negative 4 minus 4 will give us a negative 8. Take the opposite of x, which is still 0. 0 minus 4 will give us negative 4 here. So we're going to have 4, negative 4. We're going to have 2, negative 8. And we're going to have 0, negative 4. So what happened here was when we have the negative x, we reflect over the y-axis, and then we're going to shift down 4 units. All right, 47, we do need a calculator for this one, but I'm not going to ask you one on the test here. So this problem is about medical equipment that manufactures X-ray machines. The unit cost here is given to us right here, C of X. So if X machines are made, then the unit cost is given by this function. What is the minimum unit cost? So we're just trying to find the vertex of this. So we just want to go back to H equals the opposite of B over 2A, but we're really interested in K. So H is going to equal the opposite of B becomes 16 over 2 times a 0.1. So this becomes 6 over a 0.2. Which is going to equal 30. So then to find K, we're just going to substitute this in. So it becomes C of 30, which is 0.1 times 30 squared minus 16 times 30 plus this 15,233. So we're going to have 0.1. 30 squared is 900. Then we're going to get 480 minus 480 plus 15,233. Like I said, if you need a calculator for this, we can continue. So 0.1 times 90, or 900, should give us 9. Should give us 90. 0.1 times 900. It's going to give us 90 minus 480 plus 15,233. So we should be getting 14,843. So this is the minimum unit cost. And it occurs, if we had to ask this question, it occurs when 30 X-ray machines are made. Okay, so just a few more. Here we want to determine the intervals on which the function is increasing, decreasing, and or constant. So let's do increasing. So we're going to start from here. So that's going uphill left to right, and then this portion. Those are the only 2 intervals where our function is increasing. We include the endpoint. So we're going to say from -5 over to -3. And then also from -1 right here to 3. Our function is decreasing here and here, going downhill from left to right. So that's from -3 to -1, from here to here, and then from 3 to 4. And then this horizontal segment is where our function is constant. So then that occurs from 4 to 7. We would include the 7 because that's at the end. All right, for 49, graph all vertical and horizontal asymptotes. So again, vertical asymptotes come from the denominator. We'll set that equal to 0. Subtract 7, divide by 2. So it's -7/2 or -3.5. Horizontal asymptote, let's go back to the degree of the numerator is 1. Degree of the denominator is also 1. So then we just say it's y equals, we take the leading coefficients, -8 over 2. So it's y equals -4, and then we'll graph both of those. So our vertical asymptote is at -3. Again, I'm just counting by ones here, so -3.5. We'll go right through the middle here. And then y equals -4. We'll go right here. So there's our horizontal asymptote in purple, vertical asymptote in red. All right, then our last question, again, another parabola to graph, quadratic. It's in vertex form, so we have y equals -2 times the quantity x plus 5 squared plus 1. Our vertex is -5, 1. A is -2, so our parabola opens down. So let's plot the vertex here at -5, 1. It's going to open down, so we can make some values here for a table. So we have -5, 1. We'll do -6, -7, -4, -3. Again, let's do the -4 and 3. Substitute in here. -4 plus 5 is 1. 1 squared is 1. 1 times -2 is -2. -2 plus 1 is -1. So we should get this here. So that would be the same as counting over 1, down 2. Because A is -2, we have to double what we would normally count down. So there's our -4, -1, -6, -1. Start with -3. -3 plus 5 is 2. 2 squared is 4. 4 times -2 is -8, plus 1 is -7. So we're looking at -7, -7, and then -3, -7. Or counting over 2, we count down 8. So here's our parabola. All right, so be sure to practice these problems several times. You can get back into ALEKS, answer these, and then go to more practice as well.